Looking at this table, we've got a bunch of data that we've looked at in a previous example. We're going to use this data now to try and make predictions about how fat consumption is related to cholesterol level. So before, when we ran the Lin-Reg t-test, we showed that there is a positive correlation between these two variables. So let's find the line of best fit. So again, running Lin-Reg t-test on these two rows. Here again, X represents the fat consumption, and Y represents the cholesterol level. So when we run the Lin-Reg t-test, again, we're going to get a value for A and B in the equation of our line of best fit. In this case, we should get our, so double check to make sure you guys are getting the same coefficients that we get here. So when I run it, I get 106 is the constant coefficient and 1.59 is the slope. So here I'll write it in the slope-intercept form. And now let's think about how we can interpret the slope of this equation. So again, the y hat was 1.59x plus 106. So that means that our slope here of 1.59 tells us that for every 1 gram increase in fat consumption, we expect the cholesterol level to increase by 1.59 milligrams per centiliter. Okay, so for every 1 gram increase in fat consumption, we expect on average the cholesterol level will increase by 1.59 milligrams per centiliter. Sorry, 1.59 milligrams per centiliter. So with that, let's try and make a prediction now. Here we want to predict the cholesterol level of a man who consumes 65 grams of saturated fat per day. So that's telling us if x equals 6, or sorry, if x equals 65, what is y? It's essentially what we're asked to predict here. So using our y hat here as our estimator, we'll take 1.59 times x plus 106, and that'll give us something around 209.35. So that tells us roughly that someone who consumes 65 grams of fat can expect to have a cholesterol level of 209.35 on average. So here we're looking at how the equation of the line of best fit can be used to make a prediction.